So graph creates a very problem when students get from class 8 to class 9. Suddenly, every teacher all the physics teachers, whoever is teaching, they're talking about graph and graph. So graph is creating a very problem in your life, right? So what are we going to do for that? We are going to go for a very easy trick that will help us to understand any type of graph, right? So how are we going to do that? We are going to see for three things. What are the three things that we are going to see? First, we are going to look for the angle. Second, we are going to see how the angle is changing, whether it is increasing or decreasing, that depends on what slope. So angle, then slope, and then what we are going to understand, whatever the slope is representing. For velocity time graph, it is going to represent acceleration. For displacement time graph, it is going to represent velocity. So let us see how are we going to do that. So first, today our topic will be what? Our topic will be displacement time graph. Now when we are talking about displacement time graph, we have to understand this. How are we going to proceed? We are going to proceed like this. We will look for what? We are going to look for angle. Whatever the angle is going to represent, after that we are going to talk about slope. And slope gives us what? This is what type of graph? Displacement time graph. This is going to give us velocity. So we are going to go by this three-step process. What is that? Angle, slope, and slope will give us what? Velocity. So how are we going to look? See, if the angle is increases or decreases, that means slope is also increases or decreases. Okay. If the slope increases, that means velocity increases. Come, we are going to understand with the help of some examples. Let's see what examples can we go by that. The first one we are going to see in this way. You can see I have drawn few graph over here, right? By looking into the graph, one might think, sir, how are we going to solve this graph? Very easy. How are we going to solve it? It's absolutely easy. Let's see. Here in the first graph that we can see here, in the first graph, can you see I have drawn two graphs, right? One, can you see? That is, one is represented by this green color, another one is what? Blue color. Now, what did I first say? I told that we have to look for what? Angle. First angle, then slope, then what? Velocity. So let's go by this. What angle are we talking about? How the angle it is making with the time axis or the horizontal axis. So see, this is the horizontal line. So the dotted lines I am doing for here, can you see these are what? These are horizontal lines. Horizontal line means it is parallel to the time axis. Now, if we look here, can you see it has made some angle? Yes or no? I was talking about this angle. Is that clear? Now the blue one, if we be very clear over here, if I use a protector, just see, if I use a protector, can you see what is angle? What the angle it is making? It is making 47 degree. Okay, you can see here it is making how much? 47 degree. Now tell me, since it is making 47 degree, if we move like this, if we check each and every angle, if I check each and every angle that it has made with the horizontal axis, which is parallel to time axis, what do you think? Is the angle increasing or decreasing? The angle is remaining constant. Yes or no? So in this case, we can straight away write like this. Here angle is what? Constant. So first thing we have found out angle. Now whatever the angle will be, that is representing what? Slope. So tell me, what about the slope? Slope is what? Constant. Slope is also going to be constant. Why? Because angle is constant. So slope is also what? Constant. Is it clear? Now tell me, angle constant, slope constant. What type of slope is this? What type of slope is this? Positive slope or downward slope? It's a positive slope. So that is, it's a positive Slope constant means it's a positive slope constant. So that means velocity is what? Constant velocity. So the body is moving with constant velocity in positive means forward direction. In forward direction. Is that clear? Now tell me what about this green one? Now tell me what about this green one? For the green one also the same case. You do what? You make these dotted lines. You make these dotted lines which is parallel to time axis. Now we'll go for the angle. Can you see? We are going for the angle. Use a simple protector and we are going to use this is how much? 15 degree. How much? 15 degree. How much? 15 degree, right? So you can see here also for the green one also, the angle is what? Constant. So we are going to write here for green, theta is equal to, I'm writing here, theta is equals to, theta means angle, constant. That means slope constant, but it is positive. So that means velocity is also constant, positive. Okay. Now see, out of these two, the green line as well as blue line, let me mark it with like this. This is A and this one is what? B. Out of A and B, whose angle is more? Out of A and B, whose angle is more? You tell me. We can see here very properly that the angle which it has made with the horizontal line or the horizontal axis, who has made much more angle? We measured with the protector just now. So A has made greater angle with the time axis, or we can say horizontal axis. That means here A is moving with what? More velocity. Why? Because as we go by this, angle represents slope and slope represents velocity. So higher angle means higher slope means what? More velocity. So you can just understand this one is much steeper, yes or no? This is much steeper. So we can write in this way, slope of A is steeper than B. So velocity is more. Velocity is more. Got it? Now similarly, we are going to do all this graph. Very easy. Within a fraction of a second, we will be able to do this. What we have to do? You are going to tell me. Can you see? I have made the angles like this. We have to judge by the angle. We are going to use a protector here. Let's use a protector. How much angle it is making? 33. As we are going to move, so it is making 33. As we are going to move, how much angle is it making? Angle increased to 48. As we are moving, check, the angle is increasing or decreasing. We can see what? Angle is increasing. Just see, carry on. I can see what? Angle is increasing. I can see angle is increasing. So what we have understood here, so as I was measuring this, we could see here that what? Angle, that is theta. So here what we can say? Theta is increasing. Theta increasing means what? We can say slope increasing. Slope increasing means what? Velocity increasing. Okay, so we have to go by this rule. Right? So now see, the slope here is what type of slope? It's increasing. So what type of slope? Positive slope or downward? Upward slope or downward? So upward. So we are going to say here positive. So velocity is increasing. In which direction? In positive direction. This direction is very important. As you know, velocity is what? Velocity is a vector quantity, right? So that's how this angle goes in this way. Is that clear? Now let's do here. Now the second one. Let's see. We are going to use the protector. First see here. What is the angle here? (85°). What is the angle here? (78). So previously it was 85. Now it is 78. Now it is 55. Now it is 24. And now it is near about 0, 3° maybe, something like that. So that means you can see here what was going on. Here theta was decreasing. So that means slope was also decreasing. What type of slope? Upward slope. That means what? It's positive. It's positive. That means what we can say, slope of displacement time graph is what? Velocity. That is also what? Decreasing. So in which direction? In positive direction. Or we can say positive velocity, forward velocity is decreasing. So we understood this. Tell me about this one. Tell me about this one. I give you some time to do this. Okay. Now how are we going to check the angle? No problem. We are going to see the acute only. Let's judge by the acute. We are not going to make any more complication here. Already class 9 physics is a lot of complications started. So let's make it things easier. I always try to make things easier. Just see. So here we are looking for the angle. So what we can say? Theta. Here is what? Increasing or decreasing? Here theta is constant. Here theta is constant. So if we say theta is constant, that means if I just take a protector, you can see here we are taking this angle, that is 180 minus 140. So this is going to be how much? This is always constant. This is always constant, right? So when theta is constant, what we can say? Slope. What we can say? Slope is what? Constant. So slope constant. What type of slope is there? Positive or negative? It's a downward slope. So that means we are going to write here negative. So theta is equal to constant. Slope is what? Constant. So slope represents what? Velocity. So velocity is also going to be what? Velocity is also going to be constant. So when velocity is also going to be constant, what does that mean? Here velocity is constant but in negative direction. Very important. Velocity is constant in negative direction. That means think of that, a car which was moving forward in positive direction, but here in this case the car is moving what? Moving with a constant velocity in which direction? In the negative direction. Is it clear? It is of the opposite direction. So this what the graph looks like. Understanding the displacement time graph is very easier if we go by this method, that is what? Angle slope velocity. Angle slope velocity. This is how we are going to do displacement time graph. In velocity time graph it will be something else. I am going to explain in another video, that is angle slope. By the same way we are going to go in velocity time graph, the slope represents what? Acceleration. So angle slope velocity is for the displacement time graph. One homework for all of you. One homework. The homework is very easy. I'm giving a very easy homework. What type of graph, what type of motion does this signifies? What type of motion does this signifies? This is displacement time graph only. This is displacement time graph only. You have to tell me what is going on here.